Hello everyone, welcome to another tutorial. In this tutorial, I am going to discuss about 1D steady flow analysis using HEC-RAS. There are some given data here. So the first data is the channel is rectangular, then the channel length is 1000 meter, channel width is 100 meter, Mannings and can be assumed as 0.025. The discharge in the channel is 200 meter cube per second. The channel slope can be taken as last two digit of student number plus 50 divided by 1 lakh, and the downstream depth is equal to normal depth. So before going to the model, we have to understand some basic concepts here, that there is the data here which says that the channel length is 1000 meter. It is actually the long directional length of the channel, and the channel is assumed to be prismatic channel, and the flow here is steady uniform flow. So if we consider that this is the upstream portion of channel, and if it is the downstream portion of the channel or river, then if we keep our eyes from upstream to downstream, from standing in upstream side, then the left side of this channel or river will be called left bank, and the right side of the channel will be called right bank. So the concept is here that if we look from upstream to downstream, and if the flow is from upstream to downstream, then the left portion of the channel is called left bank and the right portion of the channel is called right bank. And if we take a cross section that is BB, then the cross section here will be rectangular channel, because it is said in the question that the channel is rectangular. So before going to this rectangular cross section, we have to understand another concept, that in practical, if we take BB cross section along a river bed or channel, then the cross section will be something like this, because in practical a river cross section will never be as rectangular or trapezoidal or any shape. It will be look like this. So if we consider that it is the left bank and it is the right bank, so basically a surveyor start collecting the different elevation point of the river bed. If he starts from this point, then the x coordinate of the point will be 0, and the y coordinate of the point will be from this datum. Suppose this point is 10 meter. So the x coordinate will be 0 and the y coordinate will be 10 meter. Then if he collects data of this point, suppose this point is 15 meter from the origin, so that the station distance will be 15 meter, and suppose this point is 8 meter from the datum. So here the coordinate will be 15 and 8. If he takes another point here, suppose this point is 18 meter from origin, then the station distance will be 18 meter, and think that the elevation is 7 meter from the datum. So this coordinate will be 18,7. So basically this works in practical life, but here it is said that the channel is rectangular. To define a rectangular channel, we actually need at least 4 data. So suppose there are two conditions here. It is condition 1 and it is condition 2. So in first condition, this is the channel bed and it is considered as the datum. And if the surveyor starts to collect data from this point, left portion of this rectangular channel, then the first point will be 0, 5. So this x coordinate is 0, as I said earlier, just like this, that he starts collecting data from the left bank. So the x coordinate is 0, and why the y coordinate is 5? Because we have assumed that the elevation of this point is 5 meter above the riverbed, which is considered as reference datum. So the first coordinate will be 0, 5. So what will be this point? This point will be definitely 0, 0, because the x coordinate is 0, as I mentioned earlier why it is 0, and the y coordinate is also 0 here, because this is considered as the datum, which is riverbed. Then why this coordinate is 100, 0? Because the surveyor has collected another data which is 100 meter from this left bank. Actually, this 100 meter is the channel width, which is mentioned in the question. So this x coordinate will be 100, and why the y coordinate is 0? Because this is considered as the datum. Then why this coordinate is 100, 5? Because x coordinate is 100, as I said earlier, and the y coordinate is x coordinate is 100 and the y coordinate is 5, because it is 5 meter above the datum. So the four coordinates here are 0, 5, 0, 0, 100, 0, 100, 5. So in a rectangular channel, we actually need at least 4 set of coordinates to define the cross section. Now consider another case here, which is condition 2. Suppose this is the datum, and the riverbed is 100 meter above the datum. So what will be the coordinates? And again, think that the height here is 5 meter. So what will be the first coordinate? The coordinate is said here 0, 105. So why it is 0, 105? Because suppose the surveyor has started collecting data from this portion, so the x coordinate will be considered as 0, and the y coordinate is 105. This is 105 because the riverbed is 100 meter above the datum, and the height here is 5 meter. So the total elevation from the datum is 100 plus 5, which is 105. Now this coordinate is said to be 0, 100. This 0 is the x coordinate, and why the y coordinate is 100? Because it is 100 meter above the datum. Then this coordinate is said to be 100, 100. So why it is 100, 100? Because it is the river width, which is 100 meter, and we have assumed that the channel is rectangular, and the surveyor has collected another set of data here from 100 meter from the left bank. So the x coordinate is 100 meter and the y coordinate is also 100 meter, because it is 100 meter above the datum. Then the final coordinate here is 100, 105. So this is the x coordinate, which is actually the river bed, and it is 100 meter from the left bank. And then why the y coordinate is 105? Because the river bed is 100 meter above the datum, and the height of this cross section is 5 meter. So the total elevation from the datum is 100 plus 5, which is 105. So this is the concept of a rectangular cross section, but in practical, the river bed will be look like this, as I said earlier, and the station and elevation data will be collected just like this. That one point is here, suppose another point is here, then another point is here, and it will be continued to the right bank. Then there is another concept here. In practical, suppose the flow is flowing perpendicular in the direction outside of my monitor screen. Then this will be the channel, and this will be called the leftover bank, which is actually the floodplain of a river, and this portion is called the right over bank, which is in the right side of the channel. And we have assumed that the channel slope here is last two digit of student number plus 50 divided by 1 lakh. So assume that your student ID is 50, so that 50 plus 50 divided by 1 lakh, and it will be 0.001. Now we will go to HEC-RAS model. I am using HEC-RAS 5.0.5 here. You can use other versions too. So I will open it. Then I will go to File, New Project. Then I will select a particular drive here. Suppose I am selecting drive D. Then I will create a folder here. Suppose I am creating the folder name as example number 01. Then I will click OK. Then give a title here. Suppose I am giving the title example 1 model. You can give other name too. Then after giving the title, I will click OK. Then I will click OK here as well. So our project is created. Then we will go to options, unit system, and I will give SI unit system here because our data are provided like 100 meter, 1000 meter, 200 meter cube per second. So I will select SI unit system here. So I will mark it, then I will click OK. Do you want to set the projection units to SI metric? Yes. Our unit system is also created, that is visible here, that SI unit. Now I will go to this option, which is view or edit geometric data. I will select the river reach here. Then I will left click in any of the portion of the window. Then I will double click here in any of the portion of the window. Then I will give the river name. You can give any name. Suppose I am giving ABCD, and I am giving the reach name as ABC. Basically, the river is said to be ABCD and the reach is ABC, which actually means that I am working with a portion of my river, which is ABC reach. You can also work with the whole river portion or river reach. For this particular project, I am assuming that my whole river length, which is named as river ABCD, and I am taking a portion of reach ABC. Then I will click OK. Then after creating this, I will go to the cross-sectional window. So I will left click on it. So here we can see that the river name is ABCD here and the reach is ABC. Then we have to give the cross-sectional data here. Suppose for our model, we are considering that this sectional data is given. For entering that, I will go to options, add a new cross-section. I am giving a number here. Suppose I am giving 100. Basically, we have to remember that the upstream station of a HEC-RAS river station is always higher. What I actually mean that if you give the upstream river station number as 100, then the downstream should be less than 100. You can give 90, 80, or 99, 98, 97, whatever you want, but this should be less than 100. So I am giving the upstream station number as 100. So I will click OK. You can also give 10. In that case, the downstream number should be 9, 8, 7, or 1, 0, whatever you want. So I will click OK. So we have to remember that the upstream station of HEC-RAS is always denoted as hand number, and the downstream stations respectively are denoted in lower number. Then I will give a description here, which is not mandatory, but I am giving a name here, which is upstream. Then we have to enter the cross-sectional data. So we will enter this data in anti-clockwise direction. So the first data will be 0 and elevation will be 105. Then the next data will be 0, then 100. Then the next data will be 100, 100. And the last data will be 100 and 105. Then there are some other windows here, which is downstream reach length. So what does actually it mean? That if there is a cross section here in the upstream portion, then the downstream portion there will be another rectangular cross section here. So as the river reach is 1000 meter, so the left over bank, channel, and right over bank will be also 1000 meter. But if in practical the river can be meandering or some other shapes, and the left over bank, channel, and right over bank will be different. But for this experiment, we are assuming that the cross section is rectangular and the channel is prismatic, and there is a slope here, constant slope here. So if the upstream cross section is here, then the downstream cross section is 1000 meter below this upstream cross section, downward to this upward cross section. So the LOB, channel, and ROB will be equal to 1000 meter. So we will give 1000, 1000, and 1000. Then we will assume that the Manning's n in left over bank, channel, and right over bank will be equal. In practical, it can vary, but for this particular example, we are assuming it to be 0.025 as it is mentioned in the question. Now, main channel bank station. Here, the left bank will be 0 and the right bank will be 100. So what does actually it mean? That if it is my rectangular cross section, so the x coordinate of this point was 0 and the x coordinate of this point was 100. So for the BB cross section, if the left bank is 0, then the right bank was 100. That's why the left bank data here is 0 and the right bank data here is 100. And we will keep the contraction and expansion coefficient as it is mentioned here, that is 0.1 and 0.3. Then I will give apply data. So here is my cross-sectional view. Then we have to give another cross-sectional data in the downstream portion. So I will go to options. Then you can add a new cross-section or copy current cross-section. Then there are another sets of options here that rename river station. Suppose you have entered a wrong cross-section and you want to delete that, so you can select delete cross-section. there are other options like adjust elevation, adjust station, adjust N or K values. We will discuss more about in the upcoming videos. And you can also try with these options. So suppose I am giving options, copy current cross section, then the river is selected as ABCD, the reach is ABC, and the river station. So what will be the value here? It will be a value which is less than 100. So you can give 99, 98 or 90, 80, 70 or whatever you want. Suppose I am giving 10 here, which is definitely less than 100. So I will click on OK. Then the cross-sectional data of my first station is copied in river station 10. So I have to give the elevation data here. So we will again go to the concept that so the channel slope is said to be 0.001. Then our first coordinate of this cross section was 0,105. Now the coordinates of this cross section will be 0,105 minus total channel length, which is 1000 meter. So it will be 105 minus 1000 into slope value, which is 0.001. So if we calculate that, it will be 104. So the y coordinate will be changed here because there is a slope here. So the elevation data will be changed. Now, what will be this coordinate? It will be 0,100. Why it is 100? Because the upstream coordinate was 100. So it will be 100 minus channel slope length, which is 0.001 into 1000. So it will be 0,99. Then this coordinate will be 0,99 as well, and this coordinate will be 0,104. So now we will go to our HEC-RAS window. Then we will give the data as 104, 99, 99 or 104. Then after giving all the data, we must select the apply data option. So here it is our downstream river station cross-sectional data. We will give the description as downstream. It is not mandatory, but you can give it. Then I will again click on apply data. You can also adjust elevation from the upstream by clicking adjust elevation. So what I actually mean that the river station data after copying was 105, 100, 100 and 105. And now it will be 104, 99, 99 and 104, which is actually 1 meter less. So suppose I will go to options, then adjust elevation. So what I have to do, I have to give a -1, then I will click OK. Then you can see that the elevation data has been adjusted. Then click on apply data. So here LOB channel ROB, the LOB channel ROB here will be 0, 0 and 0. So why it is 0, 0 and 0? Because as it was the upstream cross section and it is the downstream cross section. So after this cross section, there are no cross section in the downstream portion. So the LOB channel ROB will be 0 in this case. Then assume that the Manning trend will be same as before. that 0.025, 0.025, and 0.025. And the left bank and right bank will be 0 and 100 because the cross section still remains as rectangular cross section, and the x coordinate will not vary. Actually, we have done a wrong here. It was 100, 104 and 100, 100, because the channel width was 100 meter and the data was collected here. So I have made the correction in HEC-RAS. So we have to remember that the station and elevation was 0, 104, 0, 99, then 100, 99, and 100, 104. Then I will click apply data. So our cross-sectional data is given here 110. Then I will exit the cross-sectional editor. Now there are two cross-sectional data here, which is 110. We can interpolate between the cross-section. So for that, we will go to tools, XS interpolation. There are two options here, that is within a range and between two cross-section. If you want to interpolate between two cross-section, then we will select this between two cross-section. And if you want to interpolate between the whole reach length, then we will select within a reach. So for this example, we will select within a reach. Then you have to give the maximum distance between XS station. Suppose our channel length was 1000 meter, then I will interpolate in 100 meter interval. So I will give 100, then I will click interpolate XS, then I will close it. So here you can see that there are interpolated cross section here, and the cross sectional station number is always less than the upstream. Suppose that the upstream data is 100, then the interpolated cross section is 91, then the next one is 82, the next one is 73, and so on. So if we again go to the cross sectional window, then if you click on this cross sectional drop down here, river station here, then you can see that the 91 station elevation is calculated based on your slope, which was 0.001, and the channel length, which was 1000 meter. It is interpolated by HEC-RAS, and the value is automatically generated here after the interpolation. So now I will exit the cross-sectional editor. Then I will go to File, Save Geometry Data. Try to save all the data in a particular folder. Suppose I am giving a title here, which is Geometric Data. Between two words, try to give a underscore here. Do not give a blank space here because sometimes it may create problem. You can give any title, but try to give an underscore between two words. Then click on OK. So our geometry data is ready. Then I will go to the view or edit steady flow data. Then there is an option here, which is PF1. Here we will give the discharge data, because the discharge data is given in upstream, which was 200 meter cube per second, which is mentioned in the question. So I will give the discharge data, then I will click apply data. Then I will go to reach boundary condition. We can give known water surface, critical depth, normal depth, rating curve, and there is also a delete option here. So in the downstream portion, we will give the normal depth because the flow here is uniform flow. So I will click normal depth. Then we will give the slope value here, which was 0.001. So I have selected normal depth here. Then I am giving the slope value for this experiment, which was 0.001. Then I will click OK. Then I will click OK. You can edit number of profiles. Suppose I am giving 2, then there will be 2 flow data. But for this particular project, our flow data is given as 200 meter cube per second, which is actually 1 data. So I am selecting as it was. Then I will again go to file, save flow data. Then I will give a title, which will be steady flow data. Try to save all the data in a particular folder so that you can keep track. Then I will click OK. And I will close this window. Then I will go to steady flow simulation. We will give the flow regime as subcritical. Then I will go to file, save plan. We will give a title here, which will be steady flow simulation. Then I will click OK. Then give a name here, like that I am giving steady 01, or you can just give a number here. Then I will click OK. So here we can see that the plan name is steady flow simulation and the short ID is steady 01. So our model is ready. Then I will click compute. So here it is computed. So our final run is simulated. Here we can see that the computation task completing geometry steady flow computation and complete process and the time here. So if you do some wrong in this run, then the bar can be red color here, or it will give some warning here. So as our whole bar of this portion is blue and the computation process is also seen to be completed here, so our model is okay. Then I will click close. Then you can go to different options here, like if you go to view cross section, then you can see the cross sectional data here. Here is energy gradient line or water surface profile. Then you can go to the view profile, which is actually the river longitudinal cross section. Here it is actually the upstream portion and it is the downstream portion. Again, if we go to this, so you can see here that the reach is ABCD, or you can see that the profile is PF1, which was our given profile in HEC-RAS. Then you can go to this option, which is view general profile plot. You can see some plot here. Then you can go to the 3D multiple cross-sectional plot. You can see the 3D plot here. So here you can see the 3D plot here. You can change the azimuth angle or rotational angle. Here is the cross-sectional window, river station window. So you can see different data here, which is upstream river station and it is downstream river station. Then you can plot a stage and flow hydrographs. There is actually no data here in this option because we haven't given any stage of flow hydrograph, then you can go to the plot stage and the view detailed output. You can see the output here, that water surface elevation, velocity add, energy gradient elevation, or some other informations here. Then you can go to this option, view summary output. You can select a standard table 1 or standard table 2. You can also go to options plan or options profile. There is actually one profile here, so it is actually shown as PF1. You can also go to reach. Here is actually one reach in our particular project, so you can see different data here. You can also find the options from this view options, that rating curve, XYZ perspective plot, stage flow hydrographs, hydraulic property table, or other options as well. So how it is our computed model here. So it is our computed model and some basic concepts. We will discuss more about the other options or other concepts in our upcoming video tutorial. So thank you for watching the tutorial. You can subscribe my channel for other upcoming video tutorial. So thank you.